Hi, today we're looking at Functional Skills Maths Level 2. We've got the Training Qualifications UK exam board. This is past paper 9 and we're going to start with the non-calculator section. Question 1. Work out 0.082 plus 0.49. So let's write these out one above the other. And this is an addition, and so we've got something to add. I'm going to put a sort of placeholder 0 here in. Okay, so we haven't changed the value of the number, we've just got something to add to. So 2 plus 0 is 2. 8 plus 9, we've got 17. 7 carry the 1. 0 plus 4 is 4, plus 1 is 5. Decimal point, 0 plus 0 is 0. So we get an answer of 0.572. Question 2. Work out 8.246 divided by 4. So we're going to do this with the bus stop method. Write the 8.246 in the bus stop. 4 goes on the outside. So say, how many times does 4 go into 8? We've got 4, 8. So that's twice exactly. So we put a decimal point in to keep it in line. How many times does 4 go into 2? Well, 4 doesn't go into 2 because 2 is smaller than 4. So it goes 0 times. But we have to carry the 2 over because we haven't used it yet. So how many times does 4 go into 24? We've got 4, 8, 12, 16, 20, 24. So that's 6 times. And what about 4 into 6? Well, 4 goes into 6 once, but we've got remainder 2. So what we need to do is add a 0 at the end, so we've got somewhere to put the remainder. And now we say, how many times does 4 go into 20? So we've got 4, 8, 12, 16, 20. That's 5 times. So we've got an answer of 2.0615. Question 3. Work out 4 squared minus 10 times 2. So we've got to think about what order we do these. Well, the 4 squared, this comes under our indices. So that needs to be done before the subtraction and before the multiplication. So we're going to do this first. So I'll write this here. Well, what does 4 squared mean? Well, it means 4 times itself. So 4 times 4. So that's 4, 8, 12, 16. So now we've worked that out, we can replace the 4 squared with 16. And I'm just going to keep everything else as it is for now. So we've got a subtraction and we've got a multiplication. We need to do the multiplication next, because if you're thinking of your BIDMAS rules or order of operations, we would do anything in brackets, but we haven't got any brackets. Then any indices we have got, so we did the 4 squared. Division, we haven't got any division, so multiplication comes next. So we're doing the 10 times 2. I'll do that over here. Well, 10 times 2, we do 1 times 2 is 2, add the 0 to make 20. So the 16 still stays first, but the 10 times 2 can be replaced by 20. Okay, so we've got 16 minus 20. Now, remember, if we think of a number line, if we've got 0 here, 16 up here, we've got 16, we want to take off 20. Well, just to get down to the 0, we're going to have to take 16 off. And then if we want to take off 20 in total, well, we've taken 16 off, so we need to take off 17, 18, 19, 20. And if we put the numbers in, that's going to be minus 1, minus 2, minus 3, and that's going to be minus 4. So you can think of it as 20 minus 16, but then the answer is going to have to be negative. And we can write that in our answer box. Question 4. Use rounding to check the calculation below. Right, so we've got 7.1423 times 6.8967 equals 49.25830041. Okay, so we'll do some rounding. They haven't said to round to what, to how many decimal places or how many to whole numbers, but for this calculation it looks like rounding to whole numbers is going to be the most sensible thing. So we can say, well, this is approximately equal to 7, because 7.1, it's going to be closer to 7 than any other whole number. And 6.89, well, again, that's going to be close to 7. 49.258, if we go into the nearest whole number, well, then we look at the first decimal place, it's less than 5, so we can say that's approximately equal to 49. So what we end up with is 7 times 7 equals 49. Well, let's check that. 7, 14, 21, 28, 35, 42, 49. Yep, that looks good to me. So that's our check done. Question 5. And this is a 2-mark question. Casey thinks angle A is less than 120 degrees. Is Casey correct? Okay, well, we've got a straight line here, and we know that the total angles in a straight line add up to 180 degrees. So we can calculate A by doing 180 minus 64. So we can't take 4 away from 0, so we'll reduce the 8 by 1 and pass the 1 over. So we've got 10 minus 4, which is 6. 7 minus 6 is 1. 1 minus nothing is 1. So we've got 116 degrees. Well, that is less than 120 degrees. So is Casey correct? Yes. And we can see it was a 2-mark question. And we can put that in the box there. Okay, question 6. Work out, and I'm going to put my commas in here to make it easier to read these numbers. And remember, to put the commas in, you start from the end with the units and you count in 1, 2, 3 for a first comma. 1, 2, 3, comma here, and 1, 2, 3, comma there. So we've got work out 738,925 minus 245,128 minus 18,503. Okay, so 2 ways of doing it. What I'm going to do is I'm going to take away this number and then take away that number. What you could do is say, well, if I'm taking away this number and this number, it's the same as adding these together and then taking them off in one go. But what I'm going to do, as I say, is I will do this way first. In fact, I might do both methods and then we can check we get the same answer. Okay, so 5 minus 8, we can't do because 8 is bigger than 5, so reduce that by 1. 15 minus 8 is 7, but now we can't do 1 minus 2, so we reduce that to 8 and make that 11. 11 minus 2 is 9. 8 minus 1 is 7. 8 minus 5 is 3. 3 minus 4, we can't because 4 is bigger than 3. So reduce that by 1 and make that 13. Minus 4 is 9. And 6 minus 2 is 4. So we've taken this off. We now want to take off or subtract the 18,503. So 7 minus 3 is 4. 9 minus 0 is still 9. 7 minus 5 is 2. 3 minus 8 we can't do, so reduce the 9 to 8 and make that 13 minus 8, which is 5. 8 minus 1 is 7, and 4 minus nothing is 4. So we get an answer of 475,294. But as I said, we can think of this as 738,925 minus, and then add these two together. Excuse me. Now, let's see if that works. So let's add these two together first. 245,128 plus 18,503. 8 plus 3 is 11. 2 plus 0 is 2, plus 1 is 3. 1 plus 5 is 6. 5 plus 8 is 13. 4 plus 1 is 5, plus 1 is 6. 2 plus nothing is 2. Right, so we've worked out the 263,631. Now we want to subtract all of that from 738,925. So we're going to subtract this. 5 minus 1 is 4. 2 minus 3 we can't do. So reduce that by 1. Make that 12 minus 3 is 9. 8 minus 6 is 2. 8 minus 3 is 5. 3 minus 6 we can't do. So reduce that by 1 and make that 13 minus 6 is 7. 6 minus 2 is 4, which is exactly the same as this. So don't do both ways. Choose which method you prefer. Question 7. On a map, the distance between Mira's house and the cinema is 7 centimetres. The scale on the map is 1 to 50,000. Work out the actual distance between Mira's house and the cinema. Give your answer in kilometres. Okay, so the scale is 1 to 50,000, so that means 1 centimetre on the map is 50,000 centimetres in real life. We've got 7 centimetres on the map, so we want 7 times 50,000 centimetres. Well, if we ignore the zeros for now and do 7 times 5, we've got 5, 10, 15, 20, 25, 30, 35. And then put our zeros on. So we've got 1, 2, 3, 4 zeros. 1, 2, 3, 4. And count back for the end for our commas. 1, 2, 3. So we've got 350,000. That's centimetres. But they want the answer in kilometres. Well, I know there's 100 centimetres in 1 metre. So I'm going to go from centimetres to metres and then to kilometres. So we want to divide this by 100. We'll divide it by 100. We're going to just take off 2 zeros. So this is going to be equal to 3500 or 3,500 metres. I also know that there are 1,000 metres in 1 kilometre. So we want to divide this by 1,000 now. Well, we can take off 2 zeros, but we'll still need to do something else. You can think of it, instead of taking off the zeros, you can think of it as we've got to move the decimal point 1, 2, 3 places. So that's going to make it 3.5 kilometres, which we can put in our answer box here. And question 8. So let's move this up so we can try and get the whole question in. Just about. The table shows the number of students on a course at college. So we've got 10 first year students attended online classes only, and 15 first year students attended classes on campus only. Then we've got 13 second year students that attended online classes only, and 12 second year students that attended classes on campus only. One person is chosen at random. What is the probability that this person is a second year student who attends classes on campus only? Well, let's see how many students we've got in total, first of all. And it wants us to give the answer as a decimal and a percentage. So 10 plus 15, 0 plus 5 is 5, 1 plus 1 is 2. So we've got 25 first year students. Second year students, we've got 3 plus 2 is 5, 1 plus 1 is 2. So we've got 25 second year students as well. Let's add across this way as well, should all add up. But 10 plus 13 is going to give us 23, and 15 plus 12, well, we can add the units, 5 plus 2 is 7, 1 plus 1 is 2. Okay, and 25 plus 25 should give us the same answer as 23 plus 27. 3 plus 7 is 10. 2 plus 2 is 4, plus 1 is 5. So we've got 50 students in total. So although they're asking for the probability as a decimal and percentage, I'm going to work it out as a fraction first of all. So I know it's going to be out of 50 students. And we want the probability the person is a second year student who attends classes on campus only. So these are the second year students, and classes on campus only are these. So it's going to be this number where the 2 cross over. So we're going to have 12 out of 50. I'm actually going to work out percentage first because I think that'll be easier than the decimal. Now for it to be a percentage, we want it to be out of 100, not out of 50. But I know that 250s go into 100, so we just need to double the numbers. So we're doubling the 50 to make 100. So we need to do the same to the numerator, the 12 on top. We want 12 times 2. Well, 2 times 2 is 4, 1 times 2 is 2. So 12 over 50 is the same as 24 over 100, which is 24%. So let's put that in our percentage box here. We want the decimal. Well, for a decimal, we don't want it out of 100, we want to divide by 100, so we're going to move the decimal point once, twice, so we'll end up with 0.24. And that's the end of the non-calculator section. So now for the calculator section. So we've got right, and then we've got loads of digits. So I'm going to put my commas in here again. 1, 2, 3, comma. 1, 2, 3, comma. So we've got 12,540,000, and that's it. So they want this in words. So 12 million. Put my comma in. 540. Oh, I've run out of space. Put it underneath. 1,000. Question 2. Round 823.95132 to 1 decimal place. Well, the 1 decimal place would be the 9. So we look at the next digit, say, is it 5 or more? If it's 5 or more, we need to increase this number by 1. Well, to increase 9 by 1, it would take it up to 10. So we'd need to change that to a 0, but then add 1 onto this digit here. So this is going to become 824.0. Okay, question 3. Well, we can see it's a 2-mark question, but I won't have all of that on there. Okay, Bo asks a company to build a wall in 18 days. The company's builders all work at the same speed. It will take 5 builders 12 days to build the wall. Can 3 builders build the wall in 18 days? Well, if we've got 5 builders working 12 days, that means we've got a total of 5 times 12 amount of work, or days worth of work. Because you've got the first builder working let's think of this as you've got builder 1 working for 12 days, builder 2 working for 12 days, builder 3 working for 12 days, builder 4 working for 12 days, and builder 5 working for 12 days. So that's the same as 5 times 12, which we can use the calculator for, which means we've got 60 days of work. Okay. Now, we want to use just 3 builders. So if we're going to divide that amount of work by 3, each builder would have to work for 20 days. But that's more than 18. So can 3 builders build a wall in 18 days? No, they can't. Question 4. Write 0.472 as a fraction. Okay, well, this one's quite nice when we're turning them into fractions, because all we need to do is think, well, I'm going to put 472 on the top, and however many decimal places I've got, that's how many zeros I'm going to need. Put a 1 in front. And if you don't believe me, we can try it, because we can do 472 divided by 1000, and it gives us 0.472. Now, if we want it as a percentage, all we need to do is multiply the decimal by 100, which gives us 47.2%. Question 5. Put these fractions in order, starting with the lowest. So you might want to start getting the denominator the same, finding a common denominator. If it was a non-calculator question, then that would be fine. But this is a calculator question, so we don't need to do that. We can just do 4 divided by 5, 0.8. 8 divided by 5 is 1.6. 13 divided by 15 is 0.866. That keeps going. And 15 divided by 10 is 1.5. So now it should be a bit easier to see the order and compare these. We want the lowest first. Well, 2 of them are starting with 1 and 2 are less than 1. This is 0.8, this is 0.8 and more. So this is going to be the lowest. Then this here. And then which is smaller, 1.5 or 1.6? That one, then that one. So we're going to write in the original values they gave. So the smallest one we've said is 4/5. Next smallest is 13/15. Then we've got 15/10. And finally 8/5. Question 6. Kai looks online at the reviews of a hotel. Now, 1,088 reviewers would recommend the hotel. 192 reviewers would not recommend the hotel. What percentage of the total reviewers would recommend the hotel? So we're talking about percentage of total reviewers, so we need to know what is the total number of reviewers first of all. So we're going to add these two together. So 1,088 plus 192, get 1,280. So if we want to work out a percentage, it's going to be out of 1,280. We want percentage of total reviewers would recommend. So that's these ones up here. So that's the 1,088 out of 1,280. And because we want it as a percentage, we're going to multiply that by 100. So 1,088 divided by 1,280, multiplied by 100, and we get 85%. Question 7. Ashley buys a new freezer. The instructions recommend that the freezer temperature is set at below 0 degrees Fahrenheit. Ashley sets the temperature to minus 15 degrees Celsius. Has Ashley set the freezer to the correct temperature? Show how you decide. And we're told that C equals 5, and then brackets, F minus 32, all of that's divided by 9. Where C equals the temperature in degrees Celsius, and F equals the temperature in degrees Fahrenheit. Okay, so let's try. Let's substitute. Well, we can do it in two ways. They've given us the minus 15 degrees, so we could put the minus 15 degrees in here. But what we can do instead, which might be easier, if we put the 15 degrees in, or the minus 15 degrees in for C, we'd have to rearrange this to work out what F is, which is doable, but what might be easier is say, well, actually, we want F to be 0. So why don't we put F as 0 and find out what degrees Celsius we would need? So it's much easier to do it than explain it, I think. So we've got the 5, and we've got a number next to some brackets. It means we multiply it. And instead of the F, we're going to replace that with a 0. So 0 minus 32, and then that's all divided by 9. Well, 0 minus 32, that's just going to be equal to minus 32. Let's show that here. 0 minus 32, just minus 32. Okay, so we want to multiply that by 5. So that gives us minus 160. And then we're going to need to divide that by 9, which gives us minus 17.77. That's going to keep going. Okay, now we were told the freezer needs to be set at below 0 degrees. Well, we know that 0 degrees Fahrenheit would be 17.77 degrees Celsius. She's only set it to minus 15 degrees Celsius. Well, if 0 is here and minus 15 is here, minus 17.7 would be down here. So this is not going to be cold enough. It needs to be further. So has Ashley set the freezer to the correct temperature? No. As I mentioned, you could do this differently. You could put minus 15 degrees in for the C and say that's equal to 5F minus 32 over 9 and solve it that way to see what value you'd need for F. But I think it's easier to do it this way. Find out what temperature you would need for degrees Celsius and then compare it to what she set the temperature to. And that was a 3-mark question. Okay. Question 8. This is another 3-mark question. Charlie needs to paint the outside of this cuboid. And we've got the dimensions of the cuboid. Charlie thinks the total area to be painted is more than 2,750,500 square centimetres. Is Charlie correct? Show how you decide. Right, so we've got to work out the area or the surface area of this cuboid. Okay, now I'm just going to put some dotted lines in to make us see this a bit more 3D. So hopefully that will show you that when we're working out the surface area, it's not just what we can see. We've got the top, but we've also got the bottom. We've got a left side, we've got a right side, and we've got the front, and we've also got a back. In fact, what we can do is, what should we do this? Let's do a little sketch over here. If we opened this shape out, if we flattened it, we would have the top section, we'd have a back section, we'd have the bottom, and then we'd have the front. So it'd be 4 rectangles wrapped up, and then we'd have these 2 side pieces here. Okay, so in fact let's write top, I'll call it a base. we would have front, back, and then we'd have side 1 and side 2. So what we try to do is work out the area of all of these. So let's start off with the sides. So the area of the sides, well, there's 600 centimetres that way, and up this way they're 500 centimetres. So it's going to be 600 times 500. And we can use the calculator, which is 300,000 centimetres squared, but we've got two sides, so we multiply it by 2, which gives us 600,000 centimetres squared. Right, now we need to do the same sort of thing for the others. So let's think about the front and the back. They're the same. So front and back. So it's going to be 1,000 centimetres across and 500 centimetres up. So again, this is working on the basis that the area of a rectangle is the length times the width. So 1,000 times 500 gives us 500,000 centimetres squared. But we've got two of them, we've got the front and the back. So times 2, we've got 1 million. Oh, sorry, 2 times 2, underline that. We've got 1 million centimetres squared. So we're going to need this one, we're going to need this one. Now we can do the same with the top and the base. So the top is 1,000 centimetres across, like the front. But we want this dimension now, so it's going to be times 600. Which is going to give us 600,000 centimetres squared. Again, we want two of those, which is 1,200,000 centimetres squared. So we want that value as well. So we want the total. So we're going to need to add up our 600,000 centimetres squared plus our 1 million centimetres squared plus the 1,200,000. So we've already got the 1,200,000. We can add in the 1 million and the 600,000, which gives us 2,800,000 centimetres squared. Charlie thinks the total area to be painted is more than 2,750,500 square centimetres. Well, that is larger than that. So is Charlie correct? Yes. I just mentioned this is a 3-mark question again here. Okay, question 9, another 3-mark question. Stevie needs to put a rope around the pond shown below. The pond is in the shape of a rectangle with a semicircle at each end. Okay, so here are our semicircles, and here's the rectangle in the middle. Okay, Steve thinks 5 metres of rope will be needed in total. Is Stevie correct? Show how you decide. Use pi equals 3.14. So it's the perimeter we want. So we know we've got 7 metres here. We're going to have another 7 metres up here. So what we do need to work out is this distance around here and this one around here. Okay, so we've got 2 semicircles, but what we can do is we can think about those as one complete circle. Yeah. because a semicircle would be there. We're just putting them together. We know that this distance down the middle is 5 meters, the diameter, and we want to work out the circumference. Now the circumference is equal to 2 pi r, or you might also remember it as pi d, so pi times the diameter. Now we've got the diameter in this example of this question, so we're going to use this version of the formula. So we want pi, which is 3.14, times d, which is 5. So 3.14 times 5 gives us 15.7, and that's meters. So that's for both of these, because we added them together, so it's like it's one full circle. Then we need to add on 7 meters at the top, and another 7 meters down here. So plus 7, and we get a total of 29.7 meters. Well, that is quite comfortably less than 55. Well, it just thinks, she says, Stevie thinks 55 meters will be needed. Well, 29.7 is not equal to 55. So we don't have to say if it's less or more, it's just not equal to it. So is Stevie correct? No. Quite a long way off. Question 10. I'll let you guess how many marks this is. Yep, it's another 3-mark question. Robin needs to make a pipe out of liquid copper. Robin knows the density of copper equals 8.96 grams per centimetre cubed. The pipes need to have a mass of 4,480 grams. What volume of liquid copper does Robin need to use? We're told the density equals the mass divided by the volume. Well, if we use the values we've got, with the density we've got 8.96. The mass, we're told, is 4,480. The volume, I'm just going to call it V. That's what we need to work out. So 4,480 divided by something gives us 8.96. So we need to rearrange this. So what we can say is, well, this is the same as saying, well, 4,480 divided by 8.96 will give us V. Okay. So, or you can think of it as, how should we do this? So we'd have the V. So it's like we're multiplying by the V and then dividing by the 8.96. So we end up with 4,480 divided by 8.96. What you can do, if you don't like that, you can kind of think, well, let's use some real life numbers. So let's say, well, 2 is equal to 6 divided by 3. Well, if we swap these over, we can say, well, that's the same as 3 equals 6 divided by 2. Yeah, it's the same idea. We're just swapping these over. We haven't changed the value. We're not cheating or anything. We're just moving things around. So we know that V equals 4,480 divided by 8.96. Get our calculator. And we get that V equals 500. And they've given us the units already, so 500 centimetres cubed. Question 11. Morgan checks how much driving instructors charge for driving lessons. We've got the amount A charged per hour, and we've got ranges for those. So 2 driving instructors charge between £20 and £30. 9 charge between £30 and £40, 3 charge between £40 and £50, and 1 charges between £50 and £60. Morgan estimates the mean amount per hour. Morgan will not pay any more than the mean amount. What is the maximum amount per hour that Morgan will pay? So we need to work out the mean from here. If you remember, the mean is the total divided by the frequency. Well, in here, the frequency is quite straightforward. It's going to be the total number of driving instructors. So it's going to be 15. Now the total's harder because we want the total pound amount, but we've got ranges for these. So what we're going to have to do is say, well, I don't know exactly how much they're charging. So let's assume that each of them is charging in the middle of these ranges. So the midpoint, so halfway between 20 and 30. So if you want to calculate it, you can do 20 plus 30 and then divide by 2. Or you can just look and think, well, what's halfway between 20 and 30? It's going to be 25. So whatever you're most comfortable with. So halfway between 30 and 40, it's going to be 35. Between 40 and 50, be 45. And between 50 and 60, be 55. So now we've got the midpoint. We're not going to use this range anymore. Okay, we're still trying to work out the total amount. This is just the midpoint. So this would just be if there was one driving instructor. But we've got 2 driving instructors. So we're going to need to work out 2 times 25. Which is 50. And we're going to do the same for each of these. So we're working out the amount of money being charged, but for each of these, and then we're going to add them all up at the end. So we want 9 lots of 35, because we're saying we've got 9 driving instructors that are charging £35 each, 3 instructors that are charging £45, and 1 instructor that's charging £55. So add those all up. I'll start from the top. 50 plus 315 plus 135 plus 55. So we've got a total of £555. So we saw before that the mean is going to be the total, so 555 divided by the frequency, which is 15. Which gives us £37. It's always good to do a quick check. So let's think, where would the middle, or where would we expect the mean amount to be? Well, the middle's sort of going to be around here, but we've got slightly more in this group, so we'd think it should be somewhere between 30 and 40, probably closer to 40, and it's 37. So that seems reasonable. Seems like a sensible answer. Question 12. This is a 4-mark question now. Taylor is planning a road trip. The total distance is 1,860 miles. The average speed limit is 30 miles per hour. Taylor wants to drive for a maximum of 6 hours per day. How many whole days will Taylor need to complete the entire road trip, driving at the average speed limit? Right, well, they're going to be driving 30 miles per hour and wants to drive a maximum of 6 hours each day. So 30 times 6 will tell us how many miles they're going to cover in each day. So 180 miles per day. Now if the total trip is 1,860, how many 180s fit into that? So in other words, 1,860 divided by 180. And we get 10.33 days. But they want how many whole days? Well, if they only do 10 days, it won't be enough. Because if we look, 10 times 180 would only get them 1,800 miles. Not enough. So they're going to have to do 11 whole days. They might not need all of that 11th day, but it's definitely going to go into 11 days. Question 13. Izumi sells chocolate muffins and jam donuts. This table shows the number of chocolate muffins sold over the last 6 days. Here we go. This table shows the number of jam donuts sold over the last 6 days. So we've got the mean number and we've got the range. Izumi claims, on average, I sell more chocolate muffins each day. And the sales of the chocolate muffins are more consistent. Are both of Izumi's claims correct? Give a reason for each of your answers. Right, so what we want is we want to have the average, and to find out about consistency, we're going to need the range. So we're going to want that for the chocolate muffins, because we got it for the jam donuts. So now we're going to do, we want values for chocolate muffins. So we want the mean amount. So the mean amount, we've just been looking at the mean. We want the total divided by the frequency. So our total 1, 2, 3, 4, 5, 6 of these, we just need to add them all together. 43 plus 30 plus 24. 43 plus 30 plus 24. And that's why it's good to check what's going in your calculator, so you can do some mental checks while you're going along. Plus 32 plus 28 plus 35. So we get a total of 192. So we want 192. And how many have we got? 1, 2, 3, 4, 5, 6 days. Gives us a mean of 32. Now we also need to work out the range, and the range is the biggest minus the smallest. It's the difference between them. What's the biggest value? 43. Anything bigger than that? No. And smallest, we've got 24. Right, so we want 43 minus 24, which is 19. Right, so we've got our values. Now we can look at these claims. So, on average, I sell more chocolate muffins each day. Well, chocolate muffins, the mean is greater, so we can say yes. Mean is bigger. Then we've got 32 versus 28. Now for the second claim, the sales of the chocolate muffins are more consistent. Again, yes. Range for chocolate muffins is smaller. So we've got 19 versus 25. They've got the boxes to put the reasons in down here. You can see it's 4 marks. But this is all that you need to put in there. As long as you're showing the values that you've worked out as well to justify your words, that'll be fine. Question 14. Hayden needs to fill this fish tank with water. The top of the tank is in the shape of a triangle. Here. Okay, we've got the measurements on here. And we're told to work out how much water the tank holds, Hayden uses this formula. We've got the volume of the tank in cubic centimetres equals the area of the top of the tank times the height of the tank. Hayden has a bucket that will hold 11 litres of water. What's the minimum number of times Hayden will need to use the bucket to fill the tank? And this is a 5-mark question. Okay. So, first thing we need to do, well, not first thing, but we do need to find out the volume of the tank. Now, to do that, we need to work out the area of the top and also the height. Well, the height they've told us. So that's 140. That's nice and straightforward. The area of the top of the tank, well, they've drawn the triangle that way, sort of upside down. I'm going to draw it the right way up, because that's how we usually see triangles. We've got 80 centimetres along the bottom, and this height here is 30 centimetres. Now hopefully you remember that the area of a triangle is equal to half times the base times the height. It's going to be a half times 80 times 30. So half, we can put it as 1 divided by 2, or we can just put 0.5 times 80 times 30 is 1,200 centimetres squared. Okay, so that's here. So we can work out the volume now. So we can say, well, the volume is 1,200 times 140, which is 168,000, and that's going to be centimetres cubed. Okay, now that's all very well, centimetres cubed, but they're talking about litres. Now I know that 1,000 centimetres cubed is equal to 1 litre. So we want to divide this by 1,000. And that gives us 168 litres for the volume of the tank. Okay. Now we're going to use this bucket, and we know that the bucket holds 11 litres of water. So how many buckets worth can we get in 168 litres? So we want 168 divided by 11, which is 15.27, not litres, that's going to be buckets. But we can't really have 0.27 of a bucket, so we're going to need 16 buckets, because 15 won't be enough. So quite a bit, but it's a 5-mark question. And finally, if I can find it, question 15. This is a 6-mark question to finish off. Luca wants to put ivy along the top of a 40-foot long garden fence. Luca finds these prices. So it's a price per metre for different types of ivy. They will buy 18% more ivy than needed. Luca buys the ivy that has the median price. How much will Luca pay in total? Use 1 foot equals 0.305 metres. And as I said, this is a 6-mark question. Right, let's find out the median price first of all. So remember, median means the middle value. But it doesn't just mean this one because it's in the middle. The values need to be sorted first of all. So let's see, what's the smallest amount? Well, that's smallest, £1, then £1.50, then £2, then £2.50, and then £2.75. So if we rewrite these out, we would have £1, £1.50, then £2, and £2.50, and finally £2.75. So to work out the median, we're going to cross out the smallest and the largest, do the same again. So the median amount is £2. Okay. Right, so we know the price per metre. We want to work out how much we're going to need. So we know that they need to buy 18% more than the 40 foot. We know we also are going to need to turn the feet into meters. Doesn't matter which way round you do it. I'm going to add on the 18% first, I think. So we want 18%, so 18 out of 100 of, or times, 40 feet. So we're working out the 18% first, times by the 40. So we're going to need an extra 7.2 feet. So if we add that onto the 40, we need a total of 47.2 feet of ivy. We want to turn that into meters. So 1 foot equals 0.305 meters. So if we multiply 47.2 feet, it will tell us how many meters we're going to need, which is 14.396 meters. Okay. Now they haven't said that we can only buy this in exact meters, so I'm not going to change this or round this. I can use it as it is. 14.396 is the amount of ivy we need, and we are going to be paying £2 for each metre. So we're going to double this to give us 28.792, but this needs to be money, so we're just going to look at the first two decimal places. 2 is less than 5, so we can just keep that as £28.79. And that's the end of the paper. So thanks for watching, hope you liked it. Please give it a thumbs up, subscribe to the channel, turn your notifications on so you find out when I add more videos, and I look forward to seeing you again soon. Thank you.